Hey there, I'm Derek. Welcome to Tech Edge. We've talked a fair bit about edge computing on this channel before, but today we're going to break down a few related terms. In particular, we're going to look at the space between the cloud and the edge, a layer called fog computing. We'll try and help demystify what has become a confusing alphabet soup of terminology when it comes to where computing resources are located on a network. Let's get into it. So before we can really get started, it's important to understand the big picture. In this case, that big picture has the appropriately hazy name, cloud computing. A simplified definition of cloud computing is computing power that's made available as an online service, frequently by a third party. A basic example of cloud computing is online storage and file management. When you use a platform like Google Drive, for instance, the information and files you create aren't actually stored on your computer, but rather on a remote server. These servers, for all intents and purposes, are the cloud. For industrial applications, data, which can come in many forms, might originate at IoT sensors and then be sent to a cloud service such as Amazon Web Services or Microsoft Azure. That data needs to be transferred from the physical devices in the field to the cloud, and that is where edge computing and fog computing come in. Edge computing and fog computing have plenty in common. In essence, both are enablers of data traffic to the cloud. As we touched on before, edge computing happens where data is being generated, right at the edge of a network. An edge computer or server receives data from sensors and controllers and either stores it, processes it, or sends it onto the cloud. However, not every piece of data always needs to be sent to the cloud, and there are some instances where latency is so critical that data processing has to happen faster than it takes to transmit data to and from the cloud. On the other hand, sometimes on-site processing using edge devices alone simply isn't sufficient or scalable, depending on how the network is architected and the capabilities of the edge devices being used. Fog computing is a compute layer between the cloud and the edge. In a fog computing architecture, fog devices receive data from the edge layer before it reaches the cloud and further filter it down or act directly on the information received and return decisions to on-prem devices. Data can also be sent to the cloud for archiving or remote access, or analyzed at the fog or cloud layers to help inform localized learning models. Here's an example. Let's say you have temperature sensors connected to edge servers that measure the temperature every single second to watch for temperature spikes. Imagine that all of the temperature measurements every single second of a 24/7, 365 operation are sent to the cloud because that's where your data analytics tools live. By adding a fog layer, which still physically lives on site, the edge server would first send the data to the fog server over a localized network. The fog server would receive this data and, according to certain parameters that you set, decide whether it's worth sending on to the cloud or needs to be acted upon immediately. This not only vastly reduces data traffic off-site, but also reduces latency in making key database decisions. Now, of course, for simple temperature readings like this, the time, cost, and latency savings might be negligible. But now imagine if those constant temperature readings were instead much more complex information or large files like images or videos. In some instances, an edge computing architecture may be enough of a bridge between on-site devices and the cloud. But the savings on bandwidth usage and the improvements in data latency in implementing a fog layer can have huge impact depending on the application, network structure, data type, access needs, and the location on the network of key tools and resources. In a nutshell, edge computing is data computation that happens in close proximity to where the data is being made. Fog computing acts as a mediator between the edge and the cloud for various purposes, such as data filtering and analytics. Hopefully that helped clear the fog for you a little bit. Listen, you knew we weren't getting through this whole thing without at least one fog-related pun. If you stuck around to hear it, we'd appreciate it if you gave this video a like and considered subscribing to the OnLogic channel. Thanks so much for watching, and we'll see you next time on Tech Edge.